up with the combined pressure law. So remember, Dalton was working in what we call the golden age of quantitative chemistry. Chemistry with numbers. Numbers, numbers, numbers. We need numbers. So Dalton was measuring masses and pressures and temperatures and lots of numeric information. What he figured out is that if you've got a combination of a bunch of gases in a container, and they're all under some total pressure, you can figure out the pressure within the container. That total pressure is actually a sum of their individual pressures. So name me a combination of gases, a mixture of gases.
Air.
Ah! I was kind of hoping one of you would say that. You're sitting in it. Yeah, you're sitting in a SWAT at a combination of gases. Go ahead, people will think you're crazy. They'll leave you alone. Seriously, if you mutter under your breath, the effect is amplified. So, we're sitting in this combination of gases. You put a bunch of air into a canister. Have any of you ever pressurized air? So, raise your hand if you think you've pressurized air. Okay, I got 2, 3, 4, 5. The rest of you are chicken. I'm not going to commit to this. Okay, we got a 6. Who decided he doesn't want to be among the ranks of the chickens? Yeah, I think I have. We got somebody behind him on the fence. Maybe I have, maybe I haven't. None of your business. Okay, you all think you pressurized gases. All right, Mr. Hassan, you look fairly confident about the fact that you've pressurized gases. Where do you think you've done this? Why you? You look so confident. Okay, Ms. Plunkett, you jumped right on that bandwagon. Mr. Henrich, you jumped right on.
Tire.
Ah, so you suspect that tires have something to do with this. Okay. So you're telling me that you don't fill your tires with a pure gas? You don't keep a tank of nitrogen at home to fill your tires up with?
Well, I do.
Okay. Well, we'll talk about that actually. If you get your tires changed at Costco, they do fill them with nitrogen. Fancy, fancy. Yeah, it's non-reactive. It's actually very safe. And they claim that you have less leakage. I don't know. So, pure nitrogen. Well, the atmosphere. So if you're compressing just atmospheric air, how many of you have an air compressor somewhere in your life? At home, out in the garage, at a gas station that you drive by every day? Okay. What does an air compressor do? Compresses air! This is just like gas collecting bottles. What do we do with them? Collect gases. What do we do with an air compressor? We compress air. We take just air, just atmospheric air, which is 72% nitrogen, 20-some% oxygen, some percent CO2, methane, argon, all that fun stuff, helium, and we compress it. We put it under pressure in a little cylinder, pump, 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 until you can drive around on the stuff. Or ride your bike. It's crazy. It's madness. Who thought of this? It's brilliant. When we compress all those gases into your car tire, your bike tire, your basketball, your volleyball, your football, your whatever else you want to compress into a space, each of them have an individual pressure. We can figure out the pressure in your car tires, 38 pounds, 42 pounds, 20 pounds, and you need to fill up. Pounds per square inch. Of course, here in science we measure it in newtons per meter, square meter, but that's okay. That's not 32 pounds per square inch of nitrogen. It's a fraction of that is composed of the pressure of the nitrogen. A fraction of that is composed of the pressure of the CO2. So what Dalton said is, hey, this is really easy. The total pressure is just equal to the sum of all the other pressures. This couldn't be any easier. So let's do a sample problem with this.